Okay, so what we're doing is we're talking about radicals. Now, radicals, when you hear the word radicals, what do you think of? What symbol? Square root. Now, we always know it as square root, but it's actually a root symbol. Because if you actually look at a root symbol, here's a root symbol. What is technically up here above this root? A 2, right? Do we ever write that in? No, we use that one so often. That one is known as a square root. Could you have cube roots and quad roots? The only thing that changes is the number up there. So normally when we just write this in, we don't write the 2, we just normally write the roots like that, right? Okay. So that's our root symbol. Okay, now we can have like radicals and we can have unlike radicals. And what makes like radicals is they have to have the same radicand. Okay, what's the radicand? What do you take a guess? It's one of the numbers. Which part of this is the radicand? No, the 7, right underneath the root symbol. That's the radicand. Okay, so there's a radical. So if I went like this, are these like radicals? Do they have the same root? Root of 7 and root of 7. There's a positive 5 there, and what's here? A negative 1. Now, another way to think about this, guys, is pretend that the root of 7 is like an x. We have 5x and negative 1x. Are they like terms? Yeah, you learned this back in grade 9, right? So if we had 5x, right? If we had 5x and negative x, are they like terms? Can you combine them? Yeah, okay, we're going to do that with radicals. We're going to combine radicals. We're going to add, subtract, multiply, and divide. Okay? Now, what about 2 root of 5 and 2 root of 3? Are these like radicals or unlike radicals? Unlike. Well, I put them under the unlike column, so hopefully you realize they're unlike. Why are they unlike radicals? Different radicals. So you got root of 5. Root of 5 and root of 3. They're different. Okay? Let me give you some more here as examples, just to make sure this is clear. 2/3 third root of 5x squared. Ooh, fancy stuff, eh? So it's a cube root for starters, right? It's a cube root of this. The radicand is 5x squared. Okay, so as long as I have the same part here, are they the same? As long as I have the same part underneath here. Could you have anything you want in the front? Yeah, you can. It's like a coefficient. Remember a coefficient? No, they're unlike. If you miss that, then they would be unlike. So, for instance, here, look. If I had... No. So here, 5a and... Oops. Are these like radicals or unlike radicals? They're unlike. Now, they both have 5a underneath there, don't they? But what's the difference? Right, one's a fourth root and one's a fifth root. Okay. They have to be, guys, go to class, please. So they have to be the same root. Okay. No, but they were both, look, up here, the 2 is the number in front. They're both square roots, right? So they're the same, right? The 2 is out the front. Think of it as a coefficient, right? 5x, right? That's your variable, that's your coefficient. In here, the 5, the root of 5 is the radical that we're dealing with, and the 2 is like the coefficient.
And then on the other side, it was 5 and 7 and 8
but,
and 7.
Yeah, but these are both roots of 7, right? That's a 5 and that's a negative 1, so they're like radicals. Because this part, the root of 7 has to be the same.
Yeah.
Here's root of 5 and root of 3, they're different.
Down here, it's root of 5a and root of 5a.
Yes, but look here. That's a fourth root and that's a fifth root. So those have to be the same. Right, the other ones are both 2, we just don't write them in. They're both square roots. Write them in if you need to. Write in the 2s if you need to, if you missed that. Okay, so what we're going to do now is we're going to go backwards and forwards with radicals. We're going to take big radicals and simplify them, and we're going to take mixed radicals and turn them back into other ones. Okay? So this is a mixed radical? Why do we call it a mixed radical?
So that one's bigger than the radical.
No, because we have a number in the front and we have a root of 2. What I want to do is I want to put it back to everything underneath the root symbol. So I want just a root. Well, no, you don't do 7 times 2. Now, what did we get here? How did we get 7? Square root of what?
49.
Not 14. So basically, if I say, hey guys, what's the square root of 49? What would you put? You put 7. Okay? So, in other words, this 7 up the top here, could I change it? Could I write square root of 49 times square root of 2? Could I do that? Is that the same answer as the top there?
Oh, yeah.
Is it? It is, isn't it? Okay. What? Well, how do you combine them now?
51.
No, you don't add them. You times them. So what's the square root of 49 times the square root of 2? Square root of 98. You treat them... So you want to do it which way? Okay, so you want to do it this way. So you want to say 7 root of 2, and you want to say, okay, root of 7 squared times 2. You want to do it that way? Okay. What's the square of 7? So 49 times 2, and what do you get? Square root of 98? Can you do it that way? Yeah. Are both ways correct? Yeah. Some people understand it better the bottom way, right? And some people understand better the top way. Does it matter to me which way you do it? No, who cares? The bottom way? Okay. And I usually teach it the top way, so. It doesn't matter to me how you do it, right? Something you got to learn is, and it's hard as a student because you learn it one way, but sometimes teachers teach it a different way. I'm usually trying to be pretty good about showing you multiple ways, right? Because I never know how you've been taught.
I like the top way better.
Then do it that way. Okay. All right, let's do another one here. So let's do... Just hang on. Now, a to the 4. I want to take the square root of it, don't I? Well, let's do it Keaton's way to see if it makes sense. Keaton's way would be to do this, right? Put it all over here. This a is still here. But what did we do to this a to the 4th? What did we do up here to the 7? What did we do? We squared it. So what are we going to do to this a to the 4th? We're going to... No. We're going to square it. Isn't that what Keaton said to do? Okay, so what is a to the 4th squared? Raising a power to a power. 8, no. A to the 8. Do you multiply those together when you're raising a power to a power? Power to a power rule. A to the 8 times a to the 1. Now, look here. Are they the same base?
Yeah.
Are we multiplying? So what do you do with the exponents? You add them. So we end up with a to the 9. Oops, sorry. No, that looks like a 9 instead of an a. Equals a to the 9. Okay. Now, if you wanted to, could you try it the other way I did it up top there?
Okay.
It's a little bit harder in this case because you might not realize that this is, we'll see if you guys make the most common mistake here. A to the 4th, right? We want to square it. We want it because we want the square root of it. So what would it be? The square root of a to the, sorry, that's not an a. Square root of a to the what? 8. What do you think the most common mistake is that instead of putting an 8, most people put? No. Guys, what number do you take the square root of to get 4? Square root of to get 4. 16. So one of the most common mistakes is, like look here, this is what they do. They put a to the 16 because they, oh yeah, the square root of 16 is 4, but that's not what you're doing, right? You have to remember your rule. When you're dividing, you subtract. So it has to be, in this case, a to the 8 times a. You still have to end up with a to the 9. I don't care. Stop that, please. Okay, let's try another one. What?
Tell us a riddle.
Okay. Now the difference on this one is instead of square rooting it, we're now cube rooting it. Okay? You want to do it Keaton's way?
No, I don't.
Actually, I think in some ways Keaton's way is probably pretty easy. So 5b, guys, 5b, am I squaring it or am I cubing it now? Why am I cubing it? Because it's the cube root. Okay, so I'm going to cube this guy. So I'm going to raise it to the power of 3. Quad is 4. 3b squared. Okay. The cube has 6 sides.
4 little things looking things. Like where?
Okay. Okay, now careful on this one. Careful on this one. It's you have to be careful with this one. That cube that's around the b, the 5b, it means 5b times 5b times 5b. Or another way to say it is that 3 go to both of those? Yeah, okay, so let's do it that way. So 5 cubed times b cubed times 3b squared, right? Isn't that what it means? That cube goes to both of them, doesn't it? Yeah. That's a common mistake. A lot of people, they'll do the b, but you got to remember it goes to both of those. All right? What's 5 cubed? 125. Times b cubed times 3b squared. Okay, let's combine all this stuff. Let's try to get it as close, all combined as we can. Okay, now, can you multiply the coefficients in there? The stuff in front of the b's. The what? This here, the 3b squared? The squared only goes with the b, not the 3. It's already in its form. What's 125 times 3? 375. Now careful here, guys. B cubed times b squared. They're the same base. You're multiplying, so what do you do with the exponents? Add them. Okay. How did I get what? What's 125 times 3? 375. Do you see all the rules that you learned in grade 9 and 10 are all coming back together? You're using multiple combinations of them now. Okay. These can get tricky. No.
Yeah.
Okay, let's simplify. Let's go the other direction now. We're going to take entire radicals and turn them into mixed. Okay? There's an entire radical. Okay. You got to take the one that you can take the greatest square root of in this case, because it's a square root. So obviously you'd always try to take 200. Can you take the square root of 200? No. So then you start thinking of all the factors of 200, right? 1 and 200, 2 and 100, 4 and 50, 8 and 25. No, you want the largest one that you can take the square root of. What? 5 and 40, but you can't take the square roots of either of those. Which ones can you take the square roots of? 100, 25, 4. You can't take the square root of 2. Which one was the largest one you could take the square root of? 100, right? 8 and 25, not 4 and 25. Okay, so the largest one you can take the square root of is, if you break this down, you can take the square root of 100, and the other factor is 2. Can you take the square root of 100? What is it? 10. So 10 root of, what's left? 2. That's all you do. This is what we did yesterday on the test. No. Okay, so let's go to the next one. Now, this one's a little trickier. I'm not showing this. I'm going to show this common sense way. Okay, it's the fourth root, guys. Hey, could you get off the chair like that, please? Sit up. So we want the fourth root. Okay. So this is tricky. Now, if it was square root, can you take the square root of 9? Now, careful. It's not the square root of 9. You got to watch that one. This is tricky. Now, just a little side note, guys. Look. Can you take the square root of that? Are any of you thinking it's c cubed?
Yeah.
Okay, some of you might be thinking, guys. Some of you might be thinking it's c cubed. But think about it this way. C cubed times c cubed. Are they the same base? Are you multiplying? So what do you do with the exponents? Add them. So actually it's c to the 6. Oh, not c to the 9. Yeah, it would be like if you could do that, right? Okay, so that's not what you're thinking of. Okay. So let's look at this one here. C to the 9. We want to take the fourth root. So we're looking, think about this for a minute. 4 things. I want something times itself, times itself, times itself, 4 times, right? Because that's what the quad root is. All of those 4 things have to be the same, right? Can't have like a C1, a C2, a C3, a C4. They'd all have to either be C1s, C2s, C3s, C4s, right? They all have to be the same. Now think about what we're doing with multiplication. If you're multiplying and they're the same base, what do you do with the exponents? You add them. Right? Is that correct? So what if there are ones? C1, 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 C1. What do you get? C to the 4. Okay, so that would work. We could basically then, if we wanted to, don't write this down, guys. We could basically break this down into C4 and C... No, C... Work with me here. The other one would be 5. Okay, would that work? Could we take the fourth root of C4? It would be C to the 1, right? Well, let's watch. So if we do this, C1, right, would be this. Because C1 times C1, look, C1 times C1 times C1. What do you do with those exponents? You add them up. You end up with C to the 4th, right? Is that correct? Okay, so that one would work, right? Okay. So this one would work. We could say C1, fourth root of C5. That's one simplification of it. Isn't that correct? Because we went backwards, right? We'll do Keaton's way. We go backwards. It would be fourth root. We take C1 and we raise it to the power of 4, C5, right? So we end up with fourth root C4 times C5. We end up with fourth root C to the 9. Do we end up back the way we came? Yeah, perfect. Okay. So that one would work. Is it the best one to take?
No.
What do you think? What else do you think might work? Well, what did we take out of here? Did we take a C4 out of this guy? Could we take another C4 out of here? Oh, well, if we could take another C4, and we took another C4, what could we have taken out in the first place? A C8. Oh, okay, let's try that. Let's see then. So, C to the 8, what would be left over? C to the 1. Isn't that okay? Because our original one was, what was it? C to the 9. Does that work? Multiply you have the same base, you multiply, you add those together, you get C to the 9. Is that correct? Okay, now, I want to take the fourth root of C to the 8. So what I need is I have 4 numbers, and they all have to be C's raised to the same power. C what? C2. C2, 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 and C2. If they're all the same base, what do you do with all those 2's? Add them together and you get 8. So what is the fourth root of C to the 8? C2. And what's left over underneath? C1. Yeah, or C. Now this is the next part. This is what you want to write down. What? Today? No, there's more stuff coming up. Could you stop that, please? It is, but the biggest thing about this is a lot of people want to take the root of the exponent. You cannot take the root of the exponent. You have to think differently. And if you need to, what you could write down on a piece of paper is stuff like this. X times X equals X what? Squared. So therefore, the square root of X squared is X. X2 times X2 is X to the 4. So the square root of X to the 4 is X squared. Now careful, this is where it's going to get tricky. X cubed times X cubed is X to the 6. The square root of X to the 6 is X cubed. Not X to the 9, it's X to the 6. So you have to realize with exponents you add and subtract. So if you might want to write something like this down on a page. Now this is all square roots. Could you do this with cube roots? Could you do this with cube roots? Yeah, you could. So what would you write down for cube roots? Let's do it we'll do a couple on the side here just so you have them. X1 times X1 times X1. What's that? X to the cube. So the cube root of X cubed is X1. X squared times X squared times X squared is X to the 6. The cube root of X to the 6 is X squared. Does that help? I would recommend writing that down. Do that, like, probably for the extra ones, do this to about 5 or 6 maybe. Cubes, you probably don't have to go very far, like 3 or 4. Even do a quad root if you want in there too. Actually, I think I have a sheet. Let me look afterwards. I think I have a sheet already done up for you, but we'll find out in a second. No, you know what? Writing it down is not a bad thing, because basically as you're writing it down, is it another way of remembering it? Rememorizing? That's a great one. Rememorizing. Okay, so today we're going to add and subtract radicals, and I think tomorrow we're going to multiply and divide. Adding and subtracting is really quite easy, because all you do is treat them exactly the same way you treated like terms. Do you remember like terms? 5x and 2x. Are they like terms? You went into the doctor and you got 5 x-rays. Then you had to go back and you got 2 more x-rays. How many x-rays did you get in total? 7 x-rays. Are those like terms? Yes, they are. Well, you can do the same thing with like radicals. You can add or subtract them. Now, here's the deal. Are these two things like radicals right now? I have a root of 50 and a root of 2. Are they the same? No. But can we change root of 50 so it looks different? This is an entire radical. Can we change it to a mix? Okay, now watch. So root of 50 can be broken down into 2 radicals. Which 2 are they? 25 and 2 plus 3 root of 2. Okay? Now, what is the square root of 25? So 5. So 5 root of 2 plus 3 root of 2. Did I miss one?
Yeah.
Which one did I miss? Okay, so we'll go back and do that. Just ignore this for a sec, guys. We'll go back and do that last example. My fault, I missed that. Oh, there it is. What do you mean? No, we'll come back to it. Let's finish this. Yeah, we'll come back to it in a second. Okay, 48 y to the 5th. This one's tough now because we're taking the square root, so we got to be able to take this 48 and break it into pieces. So that 48 we want to break into all its factors. First off, you always try 48. Can you take the square root of 48? No. So then you try doing the factors. So 48, 1 and 48 is a set of them. 2 and 24. Can you take a square root of either of those? No, that sucks. 3 and 16. Can we take the square root of 16? That's probably what it is. Okay, so let's put that down. So 16 and 3. Those are our 2 there. We want the largest, by the way. So you stop when you find the largest. Now you could go down. You could try 4 and 12, right? But 12 can be broken down to 4 and 3, so there's another set. So 4 and 4 is 16, so we know 16 is the best one. Now, y to the 5th. Can you take the square root of y to the 5th? No. They have to be the same. So what is it? Y to the... We can either use the second or we can use the fourth. Which one do we want to use? The fourth. We want to use the larger one. So y to the fourth and y to the 1, right? Because together, does that give you y to the fifth? It does. Okay, so let's do the work now. What's the square root of 16? 4. What's the square root of y to the 4? Y squared. What's left over? 3 and y. These are way more complicated than they even were on the test. The one on the test was really quite simple. Yeah, I know, because you didn't remember it from last year or the year before. Okay.
Wait, can you repeat the answer for that, just so that I can know if I've read it or not?
I haven't done them yet. Okay, so let's go back to this one. Sorry, guys, I jumped ahead here. So this one, remember, we took the square root of 50 is 25 and 2. Then we have 3 root of 2. Now, we end up with 5 root of 2 and 3 root of 2. Are these like radicals? You check, are they both square roots? And are the numbers underneath the same? 2. So you treat them the same. Now, guys, if I wrote right beside it 5x plus 3x, just like that, what answer would you put for this one? 8x, wouldn't you? Isn't that what that means? Okay. Guys, treat that exactly the same way. It would be 8 root of... Did that x change? 5x and 3x is 8x. So 5 root of 2 and 3 root of 2 is 8 root of 2. Treat it exactly the same. It does not change. They're like radicals. That's why I put this example here on the right-hand side, because you would see that that doesn't change. All of a sudden, it didn't change to 8x squared or 8x whatever, right? The radical stays the same. But you add the coefficients that are in front of it. These two are different, then you can't do anything with them. They're not like radicals. No, so for instance, if it was, I'll just put aside here, if it was 5 root of 2 plus 3 root of 3, can you combine those two? Guess what? That is the simplest form then. You can't do that, right? You can't go past that. That would be the simplest form in this case. Okay. Okay. Next example. No, don't be scared by these things. No, they're not scary. It looks scary, but let's take it up. Wait, what? Sorry, what? Which one? We haven't even got there yet. Okay, now look at this, guys. First off, are any of these like radicals? What do we got? Root of 27, root of 5, root of 80, root of 12. Are any of them like radicals? No, okay. That doesn't help. So let's simplify these as much as we can to see if there are any like radicals. So let's do 27. Let's do that one first. So we're going to take 27, we're going to break it down into its 2 square roots. So we go 1 and 27. Okay, 27 doesn't work. What's the next set down? 3 and 9. Can we take the square root of 9? So we know that's the one we want to use because that's the largest one. So 9 and 3. Good. Plus, what about 5? 3 root of 5. Does 5 break down at all? So is this 3 root of 5 already in its lowest form? Yeah, it is. So 3 root of 5. Let's do 80. Now, obviously, 80 can break down. We tried 1 and 80. That doesn't work. Next one is 2 and 40. Nothing there. 3 doesn't work. 4 and 20. Well, 4 works, but 20 doesn't. Let's try one more. 8 and 10, but can you take the square root of 8 and 10? Either of those? Yeah. No. What did we miss something? 5 and 16. Do you think people forget about 5 and 16? Yeah, it gets lonely out there. It's one of those leftover numbers, 5 and 16. Does that give you 80? 5 times 6 is 30. Carry the 3. 5 and 1 and plus 3 is 8. Okay, 16. Is it the largest one we can take? Yeah. So 16 and 5. Shannon, go to class. Minus 2. Let's do 12. 12 breaks down into 1 and 12, 2 and 6, Well, you can't take the square root of 2 or 6, so that doesn't help. 3 or 4. Can you take the square root of 4? Yeah, okay, that's the one we want. Okay. Now, I always, if you notice, if I put the one I'm going to take the square root of first, I do that for a reason because it helps keep me organized. Try to be consistent when you do your work. You'll make less mistakes. It doesn't really matter if you put them, you can put 3 and 4 the other way around, I don't care. Okay, so let's do some math here now. Okay, careful. What is the square root of 9? So negative 3 root of, what's left over underneath? 3. Okay? All I did was take the square root of 9. Plus 3 root of 5. That doesn't change. Minus, what's the square root of 16? 4 root of 5. That's left over underneath. Now careful on this one. What's the square root of 4? 2 times negative 2 is negative 4 root of 3. Do you think that's a common mistake is to forget to multiply that? Yeah, you got to multiply your coefficients. Now look at this. Do you see some common radicals? Okay. Okay, so hang on. I see a root of 3, and I see a root of 3. Yeah? Can we combine those two? What is negative 3 minus 4? Negative 7. So negative 7 root of 3. That's one part of it. Here's another one. I see a root of 5 and a root of 5. Do any of you use that method of circling like terms? It's a common way to do it. You use colored pencils or something like that to keep yourself organized. Different shapes, anything you want. So plus 3 minus 4 is negative 1 root of 5. Okay, now, could you have written this a different way? You don't need to put the 1 in there, that's correct. So you could have put it as, you could have put negative 7 root of 3 minus root of 5. That's also correct. What else? Could you have it the other way around? Negative root of 5 minus 7 root of 3. Would that work? Yeah, as long as you have your sign. So any of those ways are correct. And? It really is quite easy, actually. As long as you get the hang, it's a matter of just getting the hang of it. Now, sometimes you're going to see modifiers in here. There's the modifier at the end. C has to be greater than or equal to 0, which means C is 0, or when it's greater than 0, what is it? No. Positive. Is it positive? Can C be negative in this case? No, because we don't want to take the square root of a negative number. Okay. Because we're just adding a modifier in here. Okay. Let's do the first one. All right, first off, are these like terms? Square root of 4c and square root of 9c, are they like radicals? Sorry. No. Can we make them like radicals? Well, we're going to try. Okay. The first one. 4 and c, is that correct? Can we take the square root of 4? Yeah, we can. What about the next one? 9 and c. Can we take the square root of c? Does that work? Square root of c? No, it at least has to be a c squared, a c to the 4, a c to the 6, a c to the 8. Any of those would be able to take the square root. Okay. What's the square root of 4? 2 root of c minus, now careful here guys, what's the square root of 9? 3 times 4 is 12 root of c. Do we have like radicals? One second. So can we subtract them? C minus 12 is minus 10 root of c. Keaton. No, what's the square root of 4? 2, so it goes outside, right? Because we can get rid of that whole thing. That's what we're trying to do when we simplify this, right? We're trying to find square roots or cube roots or quad roots that we can take of the whole thing that gets rid of it, right? And what do you think? Easy? Simple? Difficult? They're not bad. Now what's going to happen is we're going to start to multiply and divide these, and then we're going to start to solve We're going to do algebra with these. And they get a little tricky. We are done. So
Like, yeah, click it.